Okay, we are going to continue with introducing you to the structures used in LabVIEW. The next one will be the for loop. So let's open a blank VI. As always, let's split the screen to see both of them together. So we go to the block diagram, we right click, we come to the structure, and we come to this for loop, and we drag it here, and we give it a size. So you see, this is our for loop. It has two very important elements here. One of them is the loop iteration, which is named as I, and the other one is the loop count, which is named as N. What are these two? This is the I that changes every time the loop is done. So this goes from the beginning and it increases one by one, and this one is the ending count. So this increases until it reaches to this one, this loop count. This is the final amount, the final number of times that we need the loop to be done. So we should give them values. In order to give n a value, this n can be changed by us. So what should we do? We should right click, as I told you before. In order to use the beautiful feature of LabVIEW, we can give it automatically the thing that it is needed. So we right click here. What should we create? We should create, if we want to change it, we should create a control, and you see a numeric control is given to us in the front panel in order to change it. If we want that, so let me undo it. So if we wanted to give something constant that cannot be changed, we just give it a create constant. But here, in this example, because we want it to be changed, we create a control. So this is the loop count. Also, in order to see the value of the loop iteration every time a loop, the inside job of this for loop is done, we should create an indicator in order just to see what's happening there. Okay, now let's see what happens if we run this. So you see this numeric, which is this one, is the loop count. You see, so it is set to 0. It means that this for loop is should not be done even once. So we run this. This is 0, and I put it to, for example, 10, and you see that it was done very quickly. So in order to see what's happening here, let's give it some weight. So let's give weight a constant of 1500 milliseconds. It means 1.5 seconds. So let's see what happens this time. So you see, this is going up. It means that every 1.5 second, this for loop is doing the task, and this is increasing until you see 9. So it starts from 0 until 9. It means 10 times. So I think if I increase this one to, for example, 20, this time this will continue until, you see, when it was fixed, this time this will continue until 19. You see, this is going to continue until 19. So this is for loop. We can use it for several applications. One of the applications that we use for loop for is the add shift register. So what does add shift register do? The add shift register gets a number, gets an input, and then it waits for as much as the loop count, and then it gives out the input. So when we need to wait a certain amount of time in order to transfer something from somewhere to another block, we use add shift register. Let's see how that works. um, so I right click here and I click on this add shift register. You see these two appear here, and let's decrease the amount of wait to 1000 milliseconds. That means 1 second. And let's give this some numerical value. So let's give it a numerical control. Let's connect it to here and then connect these two together. And then let's put a control there in order to see the results. Sorry, an indicator there to see the result. So we simply connect these two together. So now, for example, imagine that this loop count is 10 and this wait here is 1 second. So this numeric, whatever it is, it will take 10 seconds in order to be shown in this numeric 4. So let's see if when we run it, what happens. So we run it and we put, for example, the value of 2000 here. Let's see when that appears here. You see this goes to 9. And now that value, you see, is appeared in this numeric indicator. So that add shift register is used for such an application. Okay, this was the for loop and one of its applications. You will see much more about it in the during the lab assignments and lab tasks. So let's go to the next structure, which is while loop. So in order to use that, let's first delete this. So let's add the while loop here. We drag it like the other ones, and okay, we change the size. So it has two different elements. This is like the for loop. This is the loop iteration. It shows if what is the loop count now, what is the stage of the operations inside the loop, and this one is the condition of stopping the while. So there's something very important here that you should pay attention. This while loop in LabVIEW is a bit different than the while loops that you have used in previous programming languages that you have already seen. The difference is that this while loop, when we run the program, the while loop is done first for one time, and then this condition is checked in order to continue the second stage. So it's more like a do while in other programming languages than a while. So you should be very careful about using while in LabVIEW. I repeat my sentence again. When you run the program, this while is first done for one time. Whatever inside the while is done for one time, and then this condition is checked in order to continue or not. So if you want to check something even before being done once, you should put some condition before while and then send the signal inside the while in order to be done. Okay, let's see an example. So like previous examples, let's put some switches and let's copy this switch and let's put some LEDs. Let's put one round LED. Let's put one square LED. So let's put one of them outside. Let's put one of them inside. Connect them. Also, let's define something to stop the while loop. So in order to do that, when you are writing a program, when you are designing a program in LabVIEW, you want some condition to be checked in order to stop the while or not. Here our condition can be, for example, as an example, here we use some switch to stop the while. So let's go and select the stop button and let's connect this stop button to the condition of the while. So what happens here is that so you see here a stop is if true is checked. What does it mean? It means that if this condition sends the true signal, then this while loop is stopped. So you can uncheck this in order to make it vice versa. So but here we are good to go with the stop with true. And something very important is the operation of this stop button. So let's go to the properties of this stop button. You see there are different operations defined for buttons in LabVIEW. The one that is default is this latch when released. What does it mean? It means that if we press it, you see, if when we press it and we release it just for once, this turns on. So this is not useful for us to stop the while loop, because when we only when we release it just for a very brief moment, the condition is satisfied. So what I recommend here is switch when released, so let's see if this is good. You see, this is very good for our purpose here. So when we press it, the signal is sent and this while loop is stopped. So pay attention to this, the operation type of the button that you're choosing for your while condition. So we choose that for this stop button. And now this is ready, so we run it. You see nothing is happening because we have not pressed any of the switches. So when I press this, you see this is done, and this outside the while is not done. When I stop it, so now this can happen now outside the while loop, and so this condition of stopping the while loop is now satisfied. So this was a simple example on how we use while. Let me use this moment to give some useful information about the different types of variables in LabVIEW. As you know, when we are writing a language, when we are writing a program in a programming language, we can use different types of variables like strings, like numeric values, like Boolean values. Here in LabVIEW, there's a beautiful feature, and that's the color of the how can I say the variable types. As you see, the Boolean type, which is this, and even this wire, which a Boolean signal will be flown through this wire, is green. So the color green is for the Boolean type. Let's see what are the colors of other variables. If you see this numeric we add a numeric value, a numeric variable here. You see the color orange is for numeric type of variables. Let's add a string and see what's the color for that. Sorry. So let's add a string control. So you see the color purple is for string variables, and whenever you see that you cannot connect something to another thing, that's because you see the color is different. So for example, if I want to connect this numeric to this, it will give error. You see, I cannot connect something with different type to another thing which the type of variable is different. So we cannot connect a boolean to numeric. These two are different types of variables. Also for this one. So you see these colors will be very helpful for us in order to see what is the bug of our program, what is wrong, and what can we do in order to solve that problem.